Welcome back. We're going to continue our discussion of technology and cost by introducing a tool known as the production function, which is an abstract relationship between the inputs used to produce a good or a service, the factors of production, and the level or the volume of that good or service that can be generated. We can represent a production function by a mathematical equation, but we're going to go ahead and look at a moment at utilizing a table or graph to do this. And in our first example, we're going to look at Farmer Jack, who is growing wheat. And he has 5 acres of land that he is using to grow wheat. And Jack has the freedom to hire as many workers as he would like. And what we're going to look at on the next diagram is how Jack's output, how his production in terms of bushels of wheat, fluctuates as he changes the number of workers that he is using. Okay, so we're going to have the quantity of output, Q, measured on the vertical axis, the number of laborers or workers, L, measured on the horizontal axis. And first and foremost, if Jack does not hire any workers, then he's not going to be able to produce any output. Okay, but if he hires one worker, now all of a sudden he's able to produce a total of 1,000 bushels. If he hires 2 workers total, then in total they can produce 1,800 units, which makes it look like the second worker produced an extra 800 units relative to the first. And if he was to hire 3 workers, he can produce even more, a total of 2,400 bushels. Okay, where it looks like the third worker only added an extra 600 bushels. So we can run down his schedule here in this table on the left, and then we can connect the dots. And what we are looking at now in this green function is Jack's production function, or his total product curve. You'll notice it has a particular shape, and it starts to get flatter as we move to the right, because it seems to be the case that each additional worker that Jack hires is maybe a little bit less productive than the previous one, and we'll discuss why that's the case in a moment. If we wanted to measure how productive is an additional worker, okay, we would do that using a metric known as the marginal product, specifically in the case of workers, the marginal product of labor. But we could also think more generally about the marginal product of any input, not just labor, but also capital. Okay, where we're measuring how much does output go up when we change the level of input usage, holding all other factors fixed. Okay, and I'm going to use the Greek letter delta here to denote change in. So delta Q we can think about as the change in quantity. Delta L is the change in labor utilized. And the marginal product of labor is just the ratio of those two things. Delta Q divided by delta L. And remember, Q was measured on the vertical axis in that diagram. L was measured on the horizontal. So this is really delta Y over delta X. We're actually measuring, and we'll see this in a moment, the slope of that production function, of that total product curve at a particular allocation. So if we wanted to calculate the marginal product, all we're going to do here is calculate delta Q over delta L using the table. So that first worker we hired, he caused output to go up by 1,000 units, 1,000 bushels. So the marginal product of worker number 1 is 1,000. Now, as we saw before, when we hired the second worker, we didn't quite get another 1,000 units out of him. Otherwise, total production would have been up at 2,000. So the second worker only gives us a marginal product of 800 additional bushels. Third worker only gives us a marginal product of 600, so on and so forth. Okay, so just like we had graphed the production function, we could also graph the marginal product. We'll think about that in a moment. Okay, but here is how the marginal product schedule is related to the total level of production at any given level of input. Okay, in the MPL, this is the slope of the production function. Okay, note that in our example here, as L increases, the marginal productivity of each worker is diminishing. And this explains why that production function, why that green line was getting flatter in that first diagram we looked at. Right? First worker gave us a whole lot of output. But as we hire each additional worker, the extra oomph we get from one worker starts to decrease. Okay, now, why do we care about the marginal product? Well, if you remember back to one of the core ideas we talked about at the beginning, okay, we have to think at the margin if we're rational. Okay, so if I'm a seller and I'm thinking whether or not I should hire another worker, I'm going to have to compare the benefit to hiring that worker to the cost. And the cost of that additional worker is the wage I have to pay them. But the benefit of hiring that worker would be the value of the extra output that I get, the value of their marginal product. So when we come back to profit maximizing behavior later, we'll take a look at this idea in that we need to compare both the marginal benefit and the marginal cost of hiring another worker in order to think about whether or not we're hiring the optimal number of workers. All right, now we've argued in this example that the marginal productivity of each worker is diminishing as we add more and more workers to Jack's field. Okay, why is this happening? Well, if you think about it, Jack's field, he's got 5 acres of land. That's fixed. At some point, the average worker is going to wind up being crowded. Okay, they're going to be less productive. They have to start sharing tools to harvest the wheat because there's not enough for everybody. Remember, we're holding everything else fixed. So as we add more workers, they start to bump into each other, they start getting annoyed with each other, and their marginal productivity starts to diminish. And we're going to assume that this happens at some level of labor utilization or some level of input utilization in general. So this assumption here that we face a diminishing marginal product, this is a pretty regular assumption in economics, and we're generally going to assume that this happens at some point. Maybe very early on at low levels of labor, I get one person in there, I get 2 people in there, 2 heads are better than 1, and maybe their productivity goes up. But at some point, for a fixed amount of space that they have to work, for a fixed amount of capital, okay, those workers start getting crowded and they start being less productive. So let's go ahead and take a look at Jack's costs. Okay, let's assume here he's got to pay $1,000 per month for his land. And he has to pay that regardless of how much wheat he's actually able to grow. Okay, we'll also assume here that the market wage for a farm worker is $2,000 per month. So Jack's costs are absolutely related to how much wheat he produces through how many workers he needs to hire through the wage he has to pay each worker per month. Okay, so let's go ahead now and calculate Jack's total cost of production. Okay, his cost of land, you'll notice that does not change. He's paying $1,000 for his 5 acres of land, regardless of how many workers he puts on it, regardless of how many bushels he generates. But his labor cost per month, that does change as he scales up workers, right? He's paying workers $2,000 a month. So for every additional worker he hires, his cost of labor goes up. His variable cost of labor goes up by $2,000. And I'll talk about that term variable cost in just a moment. Note that if we were to add the third and fourth columns together, we can calculate his total cost of being able to produce a particular amount of bushels of wheat. And we could graph Jack's total cost curve now. Right, let's put Q on the x-axis. We'll put total cost on the vertical axis. And this function is showing us that as we increase the quantity we produce, the cost of production also goes up, which I think is fairly intuitive. Now again, just like what we had did when we looked at the total product curve or the production function, we can also look at the slope of the total cost curve and measure how much does the cost change when we change the quantity produced by a very small amount. So similar to marginal product, the marginal cost shows us the change in the total cost resulting from a change in the scale of production when we change Q a little bit. Okay, and we can go ahead and calculate the marginal cost here by taking delta TC divided by delta Q as we move down the list. Okay, so note that marginal cost. It is definitely increasing here. Okay, just getting it higher. Right, first few units, marginal cost was $2, but then that starts to creep up. Okay, so now we can go ahead and we could think about plotting our marginal cost curve, which captures this idea in this example that MC is rising as Q rises because those workers are getting marginally less productive. Okay, and again, the marginal cost is going to be important because we need to compare the cost to the benefit for any decision we're going to make. And we'll pick up with that in the next segment.